All right, let's go under the hood of planet Earth, shall we? I mean, we're going to look way past those facts we all had to memorize back in school. We're going to try and understand our planet for what it really is, which is this dynamic, deeply interconnected, living machine. So yeah, let's dive right in.
So you think you know planet Earth, right? I mean, we all do. The basics seem, well, pretty simple. But here's a thought. What if the most important, the most powerful forces shaping our world are the ones we almost never, ever see or even talk about?
Yeah, these are the classic hits, right? Third rock from the sun, 70% water, the blue planet. They're the simple labels we all picked up as kids. And look, they're true, but they're just trivia. They make Earth sound like this static, boring object, just a backdrop for our lives. But that is so not the real story.
And this right here is the whole point. The interesting stuff isn't the trivia, it's the mechanisms. The real story is in the engines, these complex, powerful systems that are constantly running in the background. They're shaping everything, from your phone's GPS signal all the way to the weather just outside your window. And those are the hidden mechanics we're going to get into today.
Okay, so where do we even begin? Let's start with the most basic thing imaginable, the very ground beneath our feet. Because it turns out, even the fundamental shape of our world is way more complex, and honestly way more important than we're usually led to believe. You know the image I'm talking about. We all have it in our heads, this perfect, polished, blue marble, a perfect sphere. It's clean, it's simple, it's on every single classroom globe, and, well, it's also wrong. Okay, so the first layer of truth is a bit more complicated. Earth is what's called an oblate spheroid. Fancy word, but all it means is that because our planet is spinning so incredibly fast, this centrifugal force causes it to bulge out at the equator. So it's kind of squashed, like someone just gently sat on it. But you know what? Even that is still a little too neat and tidy.
And this is where it gets really interesting. The truest, messiest shape of the Earth is actually the geoid. It's lumpy. Seriously, it's like a potato. And that's because the planet's mass isn't spread out evenly at all. You've got massive mountain ranges, you've got dense rock deep underground, and all of that creates this really complex and uneven gravitational field.
So, a lumpy potato. Who cares, right? Well, you do, because our entire modern life runs on precision. This geoid, it's the essential, invisible reference map that makes your GPS work. It's what makes satellite orbits possible. It's how our models of sea level rise have any accuracy at all. It is the true, lumpy landscape our technology actually has to navigate.
All right, so we've covered the ground. Now let's move up, into the air all around us. It feels infinite, right? But what you'll see is that it's a surprisingly delicate system, where just a tiny fraction of gases are doing all the heavy lifting.
Okay, so when I say air, you probably think oxygen. I mean, that's what we breathe. But look at this chart. It's almost 80% nitrogen. That's wild. And that nitrogen is absolutely crucial. It acts as a buffer gas. It thins out the oxygen. It sets our atmospheric pressure. Basically, it keeps everything on the surface stable. Without it, our world would be, well, let's just say intense, is putting it mildly.
I love this analogy because it really puts the scale into perspective. The atmosphere isn't this vast, thick blanket we imagine. No, it's an incredibly thin shell. All of our weather, all of our life exists in this one fragile, precious coating. It's just a powerful reminder of how delicate this whole system really is.
And get this, inside that thin layer of varnish, it's that tiny little 1%, gases like carbon dioxide and methane, they're the ones that act as the planet's thermostat. They are perfectly tuned to trap just enough of the sun's heat to keep Earth from being a total ice ball. They're literally the control knob for the entire planet's energy.
All right, from the air, let's dive deep into the blue part of our world, because the oceans are so much more than just giant, static pools of water. No, they are the massive, slow-moving engine of our entire climate system.
And this is a really important concept to get your head around. The ocean has absorbed a staggering amount of the excess heat in our climate system. Think of it like a giant, slow-charging battery. This creates inertia, a lag in the system. And that's the main reason why the full effects of something like climate change can feel so delayed. The ocean is still slowly processing decades of energy we've already put in.
And here's the quiet giant behind it all, the global conveyor belt. It's this super slow-motion, deep ocean current, and it's all driven by tiny differences in temperature and saltiness. Over hundreds of years, it moves heat and nutrients all around the globe. It's this completely hidden process that fundamentally shapes regional climates everywhere, from Europe to North America. Okay, now let's talk about the forces you can't see at all, the truly invisible engines. We're talking about a planetary shield that's generated deep in the Earth's core and a slow-motion geological dance that has been regulating our planet for literally billions of years.
Just imagine this for a second. The sun unleashes a massive eruption. It sends a billion-ton cloud of superheated plasma, hurtling through space right at us. This isn't science fiction. This is a constant threat. So what on earth stops it from just frying our power grids and stripping away our atmosphere?
This is our invisible shield, the magnetosphere. It's generated by the swirling liquid iron in the Earth's outer core, and it deflects the vast majority of all those dangerous particles. In fact, the only time we even notice it is when it's working overtime, and it lights up the sky with those beautiful auroras. It's our silent protector. And that brings us to the other deep engine. Now, we usually think of plate tectonics as a destructive force, right? Earthquakes, volcanoes, scary stuff. But over millions and millions of years, this same process recycles rock and chemicals. It's a crucial part of the long-term carbon cycle that has kept Earth's climate stable enough for complex life like us to even exist. Okay, so we've pulled back the curtain a bit. We've talked about the planet's real, lumpy shape, its super fragile atmosphere, its deep ocean engine, and its invisible shields. So now, let's try and tie this all together into a whole new way of seeing the world.
Think of this as your new takeaway toolkit. Seriously, the next time you see a news story about a crazy storm or a heat wave or a flood, just mentally run it through this checklist. Ask yourself, what's the driver? What's the scale? Are there feedbacks? Is there a time lag? You'll start to see the hidden mechanics at play. And it totally transforms the news from just a series of random chaotic events into a much clearer story about a complex system that's under pressure.
So when you boil it all down, the crucial point is this. Our planet isn't just scenery. It's not a passive backdrop. It's an active, incredibly intricate machine with all these interlocking parts, all humming along on totally different timescales. And understanding those mechanisms, well, it changes everything. It's the difference between being a passenger on this planet and actually starting to read the instruction manual. So I guess the real question I'll leave you with is, what will you see differently tomorrow?